The key concept is really important for us to understand. In our work here in this lesson, we have learned how to determine the theoretical probability that an event will occur. We abbreviate that using these symbols P and then in parentheses, the event that we hope to occur. Now, if we know the number of favorable outcomes and the total number of possible outcomes, we can write that as a ratio that you see right here, where the favorable outcomes are on top and the total number of possible outcomes are on the bottom. Always simplify your ratio, or you can change it to a percent. Once we know the theoretical probability that an event is going to occur, we can use proportional reasoning to make predictions. In this case, our proportional reasoning tells us to use our probability as the left-hand side ratio, right here. And the right side ratio is going to tell us more about the predictions. Remember that what you want to have happen is always on the top, and what is going to happen in terms of possibilities is always on the bottom. Now let's take a look at some practice problems to try out what you've learned. Monique rolls a 6-sided number cube labeled 1 to 6. Find the probability of rolling a 4. If the number cube is 6-sided, then that means each side has a different number, 1 through 6. So the probability that Monique rolls a 4 is 1 out of those 6 options. There's one number 4 in the list out of the 6 numbers possible. Number 5, find the probability that Monique rolls an odd number. Well, look again at your list. We know that 6 is the denominator of our fraction or ratio because there are still 6 outcomes. But how many of those outcomes are odd numbers? Well, we have 1, 3, and 5 that are odd numbers. So there are 3 possible outcomes out of 6, which is, in simplest form, the fraction 1/2. Number 6, if Monique rolls the number cube 12 times, how many times would she expect to get a number greater than 4? So let's go back to the possibilities. All the possible outcomes are the numbers 1 through 6. The numbers that are greater than 4 are 5 and 6. So there are 2 outcomes out of 6 that meet that requirement, which is the fraction 1/3. Now we need to take that 1/3 and use it in a proportion to find out how many times would she roll a number greater than 4 out of 12 rolls on that number cube. So we're going to solve this proportion for R, which is the number of times that she would roll a number greater than 4. So we're going to multiply both sides by 12. And we get R equals 12 times 1 divided by 3. So out of 12 rolls, Monique can expect to get 4 times she would get a number greater than 4. Now I'd like for you to look back across your page at number 3. What does it mean that there is an equal theoretical probability of each outcome? An equal theoretical probability means that there are 2 possible things that can happen, or that each of the things that can happen appear or occur in equal numbers. So this could be very similar to flipping a coin, because a coin has 2 sides. dividing up into, let's say, odd and even, because odd numbers and even numbers occur in equal amounts. And sometimes even we divide things into genders, for example, male and female, or boys and girls. If things happen in equal theoretical probability, that means each of them has the chance 1 out of every 2 times of happening, or 50%. Now let's try some more practice and problem-solving work. Number 7. A spinner has 8 equal-sized sections. To win the game, the pointer must land on a yellow section. So you can see here that we have 2 yellow sections, so that's the number of favorable outcomes. And how many sections are on the spinner altogether? Well, on this spinner, there are 8 sections altogether. So the chances of winning the game by landing on yellow are 2 out of 8, which is 1/4 in simplified form, or if you change that to a percentage, 25%. Number 8, Natalie is playing a game using a fair coin. Contestants win the game if the fair coin lands tails up. The theoretical probability that the coin will land tails up is 1 out of 2. Remember that on a fair coin, you only have heads or tails. So you have 2 possible outcomes. One of them is the outcome that you want to have happen. So 1/2, or 1 out of 2, 50%, tells me all about the chances of it landing tails up. If 250 contestants play the game, how many are expected to win? Well, I want to know how many contestants would that be out of 250 if my chances of winning that game are 1 out of 2. So now I'm going to solve this proportion by multiplying both sides by 250. And the number of contestants would be 125. Number 10. A 12-sided solid has equal-sized faces numbered 1 to 12. A. Find the probability of a number greater than 10. Well, first make a list of all the numbers greater than 10 on that 12-sided solid. Those numbers would be 11 and 12. So there are 2 outcomes out of 12 outcomes that produce a probability for a number greater than 10, which is 1 out of 6. Part B says, find the probability of a number less than 5. So again, in this case, I'm going to list all the numbers less than 5 that are on that number cube, like 4, 3, 2, and 1. So this means that there are 4 possible outcomes out of 12, which is the same as 1 out of 3. And letter C, if the 12-sided solid is rolled 200 times, how many times would you expect either a 4, 6, or 9 to be rolled? Well, the chances of getting a 4, 6, or a 9 are 3 out of 12, which is 1 out of 4. So now I'm going to solve the proportion that says how many times am I going to roll a 4, 6, or 9 out of 200. So in this problem now, I'm going to multiply both sides by that 200. I'll solve this proportion. And when I do that, my R value is 200 times 1 divided by 4, which is 50. In other words, out of 200 times rolling the die, I should get a 4, 6, or 9 50 of those times. Number 11. Tamara finds the sum of two number cubes rolled at the same time. The chart below shows all possible sums from the 36 possible combinations when rolling two number cubes. How many times should Tamara expect the sum of the two cubes to be equal to 5 if she rolls the two number cubes 180 times? So let's take a look at the chart because this looks a little bit different than what we saw back on your examples. This time we see each of the possible sums that can occur when you roll two number cubes and add those two cubes up. The second row, though, shows how many different times that sum appears in the chart. So this is like a frequency. Like how many times do you see the sum of 2 in that chart? You only see it once. In this case, we're looking for the sum to be 5. Okay? And that 5 appears on that chart 4 times, and that means 4 out of 36 possible combinations would end in a sum of 5. So first of all, the probability that the sum is 5 is 4 out of 36. And if we simplify that, we get 1 out of 9. Now the question is, if she rolls that number cube 180 times, how many times can she expect to get that sum of 5? So we're looking for the sum of 5 out of 180 different rolls. So we're going to solve this proportion. We're going to multiply both sides by 180. And that sum is going to be equal to 180 times 1 divided by 9, which is 20 times. So she should get a sum of 5 on those two number cubes 20 times out of 180 rolls of the number cubes. 2 more problems to go. Number 13 is an assessment practice question. A city traffic light cycles through green, yellow, and red in 60 seconds. It is yellow for 3 of those seconds. So what is the probability, or what term best describes the likelihood of the probability of a car coming to the light when it is yellow? Well, remember, it's only yellow for 3 seconds out of the 60 seconds that it takes to cycle through green, yellow, red, which simplifies to 1 out of 20. Now you might need to go back and look at that chart that we made in the key concept in lesson 1 to use your words to describe the likelihood of running into that yellow light. Is it impossible? No, it's not impossible because the probability is greater than 0. Is it certain? No, because certain means that it has to happen every single time, which also can't be the case or you would never get through a red or green light. Just as likely as not likely is the fraction 1/2, meaning half the time it's yellow and the other half the time it's something else. But looking at the fraction here, we don't have 1/2, we have 1/20. Is that less than half or is that more than half? Well, 1/20 is less than half, so we say that it is unlikely that you will come to the light when it is yellow. Now take a look at number 14. Based on the records for the past several seasons, a sports fan believes the probability that the red team will win a given game is 3 out of 5. So I'm going to change my color here to red. So the probability that red is the winning team is 3 out of 5. Okay? The fan also believes that the probability that the blue team wins the given game is 11 out of 20. As compared to the blue team, how many more games should the fan expect the red team to win during a 180-game season? Okay, so we're looking for the expectation of the red team to win 180 game season. First, let's look at the probabilities for each team. The probability that the red team wins is 3 out of 5. So how many games would that be for the red team to win in a 180 game season? Solve that proportion by multiplying both sides by 180. And what do you get? We expect the red team to win 108 games. Now we need to do the same thing for the blue team. Remember, the blue team is expected to win 11 out of 20 of their games. So how many would that be out of 180? So now we're going to do the same thing by solving this proportion for 180, or for y rather, to see how many games we expect the blue team to win in that 180 game season. And we do expect the blue team to win 99 games. So now the question really is, how many more games do we expect the red team to win? Well, what do we need to do to find out how many more? Well, we need to subtract them. So 108 for the red team, take away 99 for the blue team, is a difference of how many? And the answer is 9. We expect the red team will win 9 more games than the blue team during that 180 game season. Now you're ready to try some work on your own.